All right, ladies and gentlemen, so the video that you just watched before should have been 4.4, which talked about polygon congruence. So now what we're going to do is we are going to move into special types of situations where you can prove that triangles are congruent to each other. So right now we are looking at 4.5, triangle congruence by SSS and SAS. So what we're going to do right now is we're going to dive into what exactly each one of these mean. So the first one we're going to look at is SSS. And what this stands for is side, side, side. And by definition, what it says, if all three sides of both triangles, so if you have two triangles and all three sides of both triangles are congruent to each other, then the two triangles are indeed congruent. So right now, by looking at these two triangles right here, I have triangle ABC and I have triangle DEF. So right now, let's go ahead and look at this. I'm going to try and prove if these two triangles are congruent by side, side, side. So let's go and look at this first one here. So right now, looking at side AB. So side AB right here has one notch on it, and side DE over here has one notch on it. So that's one side on each triangle that's congruent to each other. Okay. So let's look at the next one. So BC and EF, this has two and this has two. So that's two sides of both triangles that are congruent to each other. Then AC has three notches and DF has three notches. So that's three sides of both triangles that are congruent to each other. So right now, all three sides of both triangles are congruent to each other. So then that means both of these triangles are congruent to each other, which means all the angles are congruent and all the corresponding sides are congruent. So right now I could put triangle ABC is congruent to triangle DEF because of side, side, side. It's that simple. So if all three sides of a triangle are congruent, then they are congruent triangles. Okay? All right, so the next one we're going to look at is SAS. And what SAS stands for is side, angle, side. And what I want to go ahead and look at is the key thing here is I want you to see is the angle is in the middle. It's in the middle of the two sides here. So I want you to hone in on this word, the word included. So right now the definition says, if two sides and the included angle of both triangles are congruent, then the two triangles are congruent because of side, angle, side. And remember, I told you, the angle is in the middle. So that means if this side and this side are congruent, the angle in between those have to be congruent as well in order for it to be congruent by side, angle, side. So let's go and look at this triangle right here and look into it. So this first triangle to the left is triangle ABC, and this triangle on the right here is triangle DEF. So let's go ahead and see if this is going to be congruent by side, angle, side. Let's check it out. So right now, AB has one notch on it. DE has one notch on it as well. So that's one side that's congruent on both of these, correct? Okay. So then you have BC has two notches on it, and EF has two notches on it. So that's two lines, or two sides that are congruent on both of these triangles. But now look, the angle that is in between those two sides have to be congruent as well for it to be side, angle, side. So right now, AB has one notch, BC has two notches, and this angle has one arc on it. Let's look at the other triangle. DE has one notch on it, and EF has two notches on it. So right now, those sides match up, and the angle in between those has one arc on it. So everything right here matches up. So because of the sides matching and the angle matching, these two triangles are congruent because of side, angle, side. So I could say triangle ABC is congruent to triangle DEF. So ladies and gentlemen, side, 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 all three sides have to be congruent. Side, angle, side, a side, and the angle in between those have to be congruent for the whole thing to be congruent. Okay, so looking at this example, example one here that I have is we are going to either use side, side, side or side, angle, side to prove that triangle AMX, so AMX, so this triangle to the left here, is congruent to triangle AMY, so AMY. And so right now on this example, they're going to give us kind of some information to help us find this. So this is going to be known as some given information. So right now, given information tells me that M is the midpoint of XY. So right now, point M right here, this guy right here, is going to be the middle of XY. So what that tells me is that M is cutting XY in half. So that tells me X to M is going to be congruent M to Y. So these two sides right here are congruent to each other. Okay? So now the next thing it tells me is that side AX is going to be congruent to side AY. So let's look here. AX is going to be congruent to AY. Okay? And so now, right now, we don't have any information on angles, and then right now we don't have enough to tell me if there's another side here. But if you look here, I want you to look at this piece. So both of these triangles have AM and AM inside their names. So right now, the two triangles are sharing side AM. So that tells me that since they're sharing that side, it's the same thing. So that third side on both of those, they're congruent to each other. So AM is going to be the third side that is congruent. So if you look, XM, one notch, MY, no one notch. That tells me that's congruent. That's one side. AX, two notches. AY, two notches. So that's two sides that are congruent to each other. AM is going to be your third side that is congruent to each other. So ladies and gentlemen, triangle AMX is congruent to triangle AMY because of the side, side, side triangle congruence theorem. All right, ladies and gentlemen, so now for my second example here, I'm going to do pretty much the same thing I did in example number 1. So I need to prove that these two triangles right here, triangle RSG is going to be congruent to triangle RSH by either side, 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 or by side, angle, side here. So what's going to happen is there's going to be some information that's given, and you need to use that information to try and prove that these are going to be congruent. So let's go and look at this. So right now, in the given information, I know that angle RSG, so RSG, is going to be congruent to angle RSH, so RSH. So that means this angle right here is going to be congruent to this angle right here. Okay? And then next, side SG, so side SG is going to be congruent to side SH. So SG right here is going to be congruent to side SH. So right now, ladies and gentlemen, there's not particularly enough information just with these two things to tell me if these two triangles are being congruent. But one thing you need to notice is that both of these triangles here have RS and RS inside their triangles. So that means that they are going to share side RS right now. They're the same exact line. So again, just like the last example, these two lines are going to be congruent to each other. So that makes 1, 2, so that's two sides that are congruent, and the angle in between those are congruent as well. So that means these two triangles are going to be fully congruent because of the side angle side theorem, which makes them congruent. So again, that means since these two triangles are congruent, that means sides and the angles are going to be congruent. So I can go and say G and R and H are congruent. SRH and GRS are congruent. So these two angles would be congruent as well. And then this third angle over here, these would be congruent as well. So since they are congruent by side, angle, side, everything on the two triangles are congruent.